All right, this is Professor Snell, Fall 2018, E120, Lab 2.2, the Tugboat Cabin. This is an extension or a continuation of the tugboat hull, obviously, and make sure you're saving these parts using the file naming protocol and saving them where you can find them, because you'll be using them again to make an assembly, I'm sure. We look at our specs here. We know it's going to be balsa wood, and as with the previous part, our units are millimeters. So let's go look at our drawing. So I can tell that this is a side view coming from this direction, and here we have the wall is 30 millimeters wide, for example. This is a front view, so we can get dimensions for this wall and this wall here. But what is this we're looking at? I know this is a bottom view, and that's because this 34 millimeters is not the same as this 30. So I can tell that that 30 is actually the interior here, this interior contour, and that's the wall width. So the 34 is the overhang of the little roof on top of the walls. So I can see that we're looking from the bottom. The way I'm going to draw this then is on the top plane, but I'm going to flip it over. I'm going to draw just this interior contour and actually split it into two sketches so that I can make two different extrusions for the two different heights. Then I'm going to offset the lines from that sketch to make the sketches for the roofs. Then I will draw this smokestack as a circle and extrude it, and then this guy, I guess it's a flagpole, is very similar to the one we did in Lab 2.1. So we already know how to do that. We're going to draw that on the front plane and revolve it. All right, let's get started. One thing though to point out is that I'm not going to use these exact dimensions here. I'm going to just draw this interior sketch, so I will extrapolate dimensions from this drawing for that. So let's open up a new ANSI millimeters template, which we've provided for you. You can make your own. I'm going to turn off my planes, go to the top plane, start a sketch. Let's start with a center, a construction line that's going to be a center line in this case. Go out some distance, doesn't really matter at this point, but not massive. I made it 85. Then I'm going to come up and I'm going to draw just half of the part and then mirror it. Remember, I use that little nifty trick there to switch from line to arc. You don't have to do that, but I'm always looking for ways to speed up. You may want to know that S is a shortcut. It's a context-specific shortcut key. So I hit S, and all my sketch entities and smart dimensioning came up. If I were editing a feature, a different set of commands would come up if I hit S. So you may want to think about using S. I'm going to go ahead and add some dimensions now. I know that this is 17, because, no, actually 15, sorry, it's 30. This, I believe, is 68. Let's check and see. And you'll see something weird happen there, and we can talk about that in a second. So, yeah, if I'm going from here to here, that's going to be 68, because we know that this is 2 millimeters. Let's see if we can fix this. So, this was because I had drawn this not to scale. And so when I added this dimension, it actually pulled that line above the geometry that I was trying to create. So let's just see if I can pull this up. I can. But the lesson there is that we want to try to keep our geometry similar to the actual relations that we're going to add later, so that we don't get those kind of distortions. Remember, as we're drawing geometry, even if it looks right, SolidWorks has no idea what it is until we define it. Okay, if we look here, we know that this is a tangent relationship on this arc. I think, let's just see what happens if what's going to happen if we go ahead and just mirror this now. Let's just try it. So I'm going to select what I want to mirror by left-clicking and dragging a box around the things I want to mirror. So those four, or all this stuff comes up. I'm going to actually get rid of the dimensions. Don't need that. And I'm going to come up here to mirror entities, and basically these are showing me the entities that I've chosen to mirror. I'm going to copy I'm going to mirror about this center line, and there we see that we now have the complete approximation of the geometry, and this side now is symmetrical to this, so anything we do, that's what these relations are. Anything we do here should also change down here. First thing I want to do is see what happens if I make these tangent, because we know that is a tangent relationship there. I selected those two, they're tangent, so we have that shape. But okay, so what's wrong here? I did this on purpose just to show you that you should be able to you need to be able to fix your sketches. You'll see that I didn't add this line, and that's becoming obvious that this is not the right shape. I'm going to go ahead and just delete that arc and add another line. And an arc that's going to be, and I'm going to make this arc, the center of the arc, coincident with the middle or the center line. That made this a tangent relationship. I'm going to bring this endpoint up coincident with that center line, and now I'm going to add my dimension for the arc. So now if I mirror these two entities, oops, I'm going to mirror these about the center line, then we're back to where we wanted to be with our basic geometry defined. But we're still not fully defined because, of course, I haven't added this dimension. So this is a typical, like if you're in a hurry, you may do things in this manner. It's not the most organized way of doing it, but you see that SolidWorks is very forgiving, and because we did mirror this part of our sketch here, that anything to the other half, this part is based on that part, so when I change the dimension here, it changes it here. So we're all good. Now I'm ready to make my extrusion, but not quite yet, because I want to split this part in half, or not in half, into two parts, so that I can do two different extrusions using sketch contours. So let me go to an isometric view and extrude my sketch. We see that selected contours pops open in my boss extrude feature. That's asking me what part of the sketch I want to. So SolidWorks sees that this is a complex contour. It's got two closed contours making up the sketch. So I need to tell it what I want to extrude right now. So I'm going to extrude these two sides, or this area here, by clicking on it and go up 40, because I remember from looking at my drawing that we need this smaller cabin to go up 40 and the taller one to go up 60. So I'm going to say OK to that. And now I'm going to open up my feature, select the sketch, and extrude the second half of the cabin up 60, or I guess the different cabin, whatever you want to call it. And so now I have this basic shape. Does that seem related to this guy? I would say, yeah, I think that we're looking good in terms of this basic. This is an isometric view. These two look very similar, so I think that we're doing fine. Let's now make our roofs, and the way I'm going to do that is I'm going to offset entities. I'm going to select the top of the cabin, make a sketch, and then click on Offset Entities up here in my sketch command manager, and you'll see that it just offset these 4 lines. Now the reason it did that is because these are the only lines that it could offset from that face or that surface. So once again, SolidWorks is guessing for us, and guessing correctly this time. I need to change that to my parameter to 2 millimeters, and now I'm ready to extrude my roof. It's 5 millimeters. I know from if we look at our drawing, we'll see that these roofs are 5 millimeters. So I select OK, and I've got that first roof. One thing I should point out that we probably haven't looked at before, I'm going to edit that roof again. You see this merge result box? That means that this feature is going to merge with whatever it's touching. So even though that overhang went into this cabin, it's not going to add anything there. It just is only going to make the part of the extrusion that is not already existing in the part. Now I'm going to go to the top of this part of the cabin, draw a sketch, or make a sketch, offset entities again, and we see now it's already remembered the 2 millimeters. So I select OK, come up here, extrude, it remembers the 5, so I can select OK, and so very quickly I can get those roofs on there. So we're now ready to do our smokestack and our flagpole. The smokestack I'm going to draw on this surface, the top of our roof. I'm going to come in here and change my display state so I get rid of the shadow that's here. I think it's easier to draw. I'm going to draw a circle that's horizontal with the center line, or the origin, I'm sorry. I know from the drawing that it is 20 millimeters in diameter. So I'm going to add that, 20. Needs to be the center of this circle needs to be some dimension from the outside of this wall. What is that dimension? Looks like it is 30, so we need to draw it 30. We need to put this center point 30 millimeters from this edge. So this needs to be 30. I also want, this needs to be, the center of the circle needs to be in the center of this roof. I know that this origin is in the center, so if I make those horizontal, it already was there because I drew it based on that dotted line coming out, but the actual relationship wasn't there, so I had to add it. Once I did that, I'm fully defined, and I can remember that Control 7 is isometric view. I can come to features, extrude. I think it is, we're extruding 50 millimeters, so it's 50. Okay, so we have our smokestack. Let's now draw our flagpole. Like we said before, it's on the front plane. It's basically exactly what we did before in the last exercise. So we're drawing a sketch on the front plane. Let's look at our, you remember in the other exercise when we drew the flagpole here, we drew it from the base of the boat hull upwards. That's because our dimensions were there. And the reason that was true is because remember this line here is a curve, so we couldn't draw directly on that, so we would have to draw under it to some degree, would be the easiest. So we might as well draw it from the bottom where the dimensions were referenced. Here we have a flat surface, so we can draw from that flat surface up. But we're still, the sketch still is oriented on the front face because we're going to draw half of this geometry and revolve it around this center line. So let's do that. We see that, and this is where the center line is going to be. We can tell from here. This is the flat face, and this is the arc. So this is where our center line is. In our drawing, that center line is actually going to be solid because we need a solid contour, a closed contour to complete our revolve. So I'm going to continue to make my little box here. I'm going to bring this just a little bit below the other line. I'm going to go ahead and add, and making sure that, so these are vertical, this is horizontal down here, it's coincident with the top of this cabin. I'm going to add some dimensions here, 3, because this is a 6 millimeter in diameter pole, and make this 50, because again, we're at 50 to the center of this arc. And I'm just going to keep this down. That's actually fine there, maybe. This just needs to be a little bit below the center of the arc, because when you have space for the arc. Now I'm going to draw an arc, a center, a 3-point arc, 1 point on that, the top of that line, that vertex. Come over and make it horizontal, the other point, and come up just somewhere around the 6 that we know is going to be our or radius of this arc. Now I need to add some dimensions. This center actually needs to be coincident, or I'm going to merge it with the center of the or the end of this center line, which is at 50 millimeters. And merging is the same as making something coincident, basically. It's placing that, I mean, that's not exactly geometrically true, but it's close, and it's basically those 2 points now occupy the same space in the universe. I'm going to select these two endpoints of the arc and make them horizontal. Now I need to continue to make this a closed contour, so I need to finish off my center and then trim with power trim that line. So now we have a closed contour. Remember, power trim is you select trim entities. Power trim is usually the default, but you select it if you're using it, and then it's a left click and then hold and drag over the line that you're trying to that you want to trim. You can also extend and just mess around with that. There's other options. So now I need to add the radius here, which is 6, and we can see now that we're fully defined. So I can go to an isometric view. Remember, you don't have to leave your sketch to access your features, and that's the fastest way of doing it, is not to leave it, because now SolidWorks knows which sketch you're going to operate upon. So I'm going to revolve, and I'm going to choose, it's asking me for the axis of revolution. I'm going to revolve around this center line. Select OK, and now we have that geometry completed. We're going to Control 7, so I have an isometric view. Change my display state back to the shaded. I think that looks good in terms of this geometry here. So let's add our material and see where we are. Select Edit Material, come down to Wood or Woods, and it's Balsa. Apply and close. Let's see how our mass is looking. Mass properties 35.43. I believe that's exactly correct. Let's go back up here and check. Yes, 35.43. This volume here is 221,428.34. 221,428.34. That's exact. Now, that's not always going to be the case. And I have in class discussed the concept of just percent difference and percent error. This would be percent difference because we don't really know which one is correct. We're just trying to compare two numbers. But if you're, we're talking about 221,000 cubic millimeters. If you're 0.6 cubic millimeters off and you run the calculation for percent difference, you'll come up with like 0.000005% different or something. That's we could build a space shuttle with that, so we're not worried about it. And I think the explanation for why that happens sometimes, I'm just using my common sense here, but these are complicated mathematical equations that are making this geometry, right? And so if we do that, and there has to be some rounding. You can't do it to to the infinite decimal places. So the order in which you would add these features or put these calculations into practice or into effect, essentially, if those are different, could see how you have a slightly different rounding result. So I think that might be what's going on. But the point is, start to use your common sense. When is it an issue and when it isn't it? If we look at the mass, if we're 0.5 off in our mass, that's a pretty significant percentage, because we're only at 35 grams. So for 0.5 grams off, that's much higher than 0.5 cubic millimeters out of 221,000. So always, this is a design class. Basically, you need to be thinking about in sort of common sense as to how your design is moving forward and whether or not you need to be worried about being more exact than you are. Engineering and design is always an approximation. There's just a chosen level of tolerance. So that's something to think about. All right, so we are done with this lab. See you next time.